Well, one of the most important parts of your camera is its lens. The quality of lens is important. Some ways the quality of lens is as important as your digital array. Variety of different terms you'll hear for different lenses: a wide angle, a normal, a telephoto, a zoom, or a macro. Let me briefly explain each one of these. Wide angle lens gives you a wide angle view. It incorporates more from top to bottom, left to right, than these other lenses, a normal or telephoto, will. It's usually a way where you can work closer to subjects. Street photographers often use wide angle lenses, but they have a lot of uses, and frankly, they're a fairly regular lens for most photographers. These numbers here are what are called focal lengths. The focal length, generally speaking, there's some exceptions to this, but generally speaking, tell you the angle of view that your lens encompasses. A macro is one of those exceptions, so we'll get to that in a minute. A normal lens is usually around a 50 millimeter for a DSLR camera. A normal lens is a lens, it's called normal simply because it has the least amount of lenticular distortion. All lenses distort space. Some lenses acutely distort space. Other lenses subtly distort space. A normal lens is considered a normal lens because it has the least amount of that lenticular distortion. A telephoto lens is like a binocular. It brings distant subjects closer to the camera. One feature of a telephoto lens is it compresses space. You see telephoto lenses used in films all the time. If you've ever seen an old cowboy movie, for example, and you see the cowboy riding on the horse, and it looks like there's great big mountains right behind the cowboy. Well, generally speaking, that's the use of what's a long telephoto lens. So usually the higher that millimeter, the higher the number, the longer the lens, the more that it zooms into that other space, or the more that it acts as a binocular and brings that other space closer to you. So if it looks like the mountain's right behind the cowboy riding the horse, it's because the telephoto lens is so extreme that it's compressing all that space. It's bringing it forward closer to the camera lens. The zoom lens works similarly if it has a telephoto setting. And many zoom lenses, I have a zoom lens on my Nikon. It's 28 to 300 millimeter, I believe. And so I go from wide angle to telephoto all within one lens. There's advantages to that, and the advantage is that I don't need a wide angle, a normal, and a telephoto. I have one all wrapped into one. And so with zoom lenses, you'll generally see that they're listed something like I have here, 70 to 210. That shows you the focal length range that your camera lens allows. And basically how they do that is once your lens is screwed onto the camera, they measure from the exact center of your lens, focused at infinity, to the digital array on the back of the camera. But a zoom lens allows, again, a variety of these different lens options all in one. The telephoto and the zoom telephoto work a little differently. The zoom telephoto optically brings middle ground closer towards you, but it doesn't compress the background space in the same way that the telephoto lens does. There's less compression with the zoom lens, generally speaking, and so that is a little bit of a difference. And frankly, I'm not an expert in optics, so I don't really know how they do that. But your lens is made up of what's called elements, and those different elements are concave and convex pieces of glass. So it's not uncommon for a lens to be made up of 7 or 9 different pieces of glass within the casing or housing for that lens. And the macro lens is a close-up lens, and so it deviates from the normal listing of millimeters. The higher the millimeter, the more the telephoto effect of your lens. With macro lenses, that's usually not the case. So again, the focal length is the exact center of the lens, and so I'm showing you a top view of a lens looking down on the lens. So the exact center of the lens when it's focused at infinity. So in a zoom lens, they would move the focal length out, focus at infinity, measure that, etc. But anyway, the exact center of the lens to the sensor plate in the back of your camera. And if that's 50 millimeters, that's a 50 millimeter lens. Explanation of the angle of view that you have in these different lenses. So the angle of view on a wide angle lens, your lens, which sits here in your camera, you see more from left to right, top to bottom, than you do with a medium or a telephoto lens. Each one narrows the focus of your viewfinder. Again, some internet images that I found showing you examples of this. The 28 millimeter on the camera there on the upper left-hand picture shows you a wide view of the scene. When you put that at 50 millimeters, it narrows the focus. 70 narrows it even more, and 200, a telephoto, narrows it extremely from what you have at your starting point with wide angle to telephoto. So that's the difference in those different kinds of lenses. One of the most important features of your lens, other than focus, is depth of field. The term depth of field references what's in focus in your picture from near to far, from foreground to background. Your camera lens has what's called an aperture. The aperture is like an iris in your eye. When you go into a dark room, your iris opens up really wide and lets a lot of light through so that the light hits your brain and allows you to focus and see and all that kind of stuff. Well, the camera lens works basically the same way. You have a small number which indicates a wide opening. So in this lens, we'll just say f2 is the widest aperture, so I have that fully open. As I stop down to the different openings, I'm letting less light strike the film. And this is just like the iris in your eye. So you go into a dark room, your iris opens up. You then walk outside where it's bright and sunny, your iris closes down. It allows your eye to control the light, for your brain to control the light. Well, your camera lens works in that same function. You have different what's called f-stops, and the higher the number, the smaller the hole. But one of the features of the smaller hole is the smaller the hole, the more depth of field, the more that you can see and focus from near to far. I can give you an example how to try this yourself just with your human eye. And you may feel silly doing this. Do it if you want to, don't if you don't, obviously. But you can hold your finger up in front of your face about a foot away. And you can focus on your finger. And my guess is the background behind your finger, everything's out of focus. Or you can focus on the background and your finger's out of focus. But if you focus on your finger and then kind of squint, it will bring the background into focus a little bit. Well, your camera lens is doing that exact same thing. As you're stopping the lens down, you're kind of squinting that lens a little bit, and it sees more in focus from near to far. So these numbers on your lens, or might be available to you on readout screen on your camera, but the numbers are important for you to understand. Well, I've given you a formula down here how they arrive at the numbers. You don't have to know that. This is just for your edification. They take the focal length of the lens, divide that by the actual size of the opening. If that's 50 millimeters divided by 17.8 millimeters, that ends up being 2.8. Well, that's f.2.8. That would be an f-stop between f2 and f4, and you see that actually on that camera sample. But I'm going to go over this a bit because this is an important feature for you to know. And it's also one of your creative controls on your camera, is how much depth of field you use. So at f4, again, f4 is a pretty wide opening. You're letting a lot of light through. At f4, you get a certain amount in focus, but not a lot. At f8, which is actually two stops difference, there's f4, f5, 6, f8, two full stops difference, you're starting to see your image is in a bit more focus. And then one stop down to f22, you can see you have foreground as well as middle ground and some background in focus in ways that you certainly couldn't see at f4. So this is one of your creative controls. Whether you want to get as much in focus from near to far as you can, you would stop down. Or if you want to use selective focus in a way that allows you to focus on some things and allow other elements to go out of focus, therefore downplaying their presence in the photograph. It's one of your creative controls, so it's one of the things that you need to think about. Well, the full f-stops on normal camera lenses, and your first f-stop here and your last one here, your widest and your smallest, might be a variance from this, but these most lenses will have f2, f2.8, f4, f5.6, f8, f11, f16, f22. Well, I showed you how they derived the number because I wanted to show you that in a way it would be easier if these just went like 2, 4, 8, 16, 32, each one doubled. The math would be easier. But what you need to remember, and you should become familiar with these numbers because it becomes a little even more confusing with most electronic digital cameras. But with these numbers, each one, as I stop down from f11 to f16, I've cut the light by exactly 1/2. I've cut the size of the opening by 1/2. If I go from f11 and open up to f8, and close down and open up are terms that you're going to hear me say and you're going to hear other photographers talk about. So that's what we're talking about, is if I stop down from f11 to f16, I've cut the light by 1/2. Conversely, if I open up, I go from f11 to f8, I've now doubled the amount of light. So each one of these f-stops is 1/2 or twice the amount of light as its neighbor. That's important for you to know. So if I started here at f8 and then I stop down to f11, I've cut the light by 1/2, and I go again from f11 to f16, I've cut it in half again. So from f8 to f11, 1/2, to f16, it's actually now 1/4 of the amount of light as it is at f8. So this is where the numbers can be confusing. You double 8 and you get 16. You think, well, that's one stop because it's half or twice. But no, the numbers mean something slightly different. It's the size of the opening. So get used to these numbers. Even memorize them if you have to. These are full f-stops. Because confusing the issue is that most digital cameras allow you 1/2 or 1/3 stops in between each of these full stops. We'll talk about that a little bit more as we go. So the aperture or f-stop in your camera, again, full stops allow 1/2 or twice the amount of light as its neighbor. And what you're about to find out is that corresponds to the shutter in your camera that does the same thing. Most digital cameras also have options for 1/3 or half stops. So in my example down here, you can see, and again, if you notice from our previous chart, f5.6 and f8 is one full stop. If I go from f5.6 to f8, I've cut the light by 1/2. But most digital cameras have 1/3 or 1/2 stops in between. Some digital cameras have 1/10 stops in between the different stops. So it allows you to even more fine-tune the exposure of your file. The other important part of your camera lens is focusing. A lot of digital cameras allow you to either manual or autofocus your camera. That's what this is, manual focus or autofocus. Generally, you'll have that switch on the camera lens or on the camera body. If not, this is your focusing ring. And frankly, whether you shoot autofocus or manual focus, that's really up to you. I generally try to do manual focus. I think I have a better sense of what I want in focus than the camera does. Generally, what the camera will do, it sends out a little thyristor beam. It's like a little sonar beam. And the first thing it strikes in the middle is usually what it focuses in on. Well, if what's in the middle is what you want to focus on, that's fine, but sometimes that's not the case. So my view is, why cede control to a camera? The camera's dumb. It doesn't know what you want. You do. And so if you cede control of the camera, you may not always get the results you want. When you take control of the camera, more often you're going to get the results that you're hoping for. This is a feet and meter scale. So whether you read in feet or meter, most of us probably look at feet more than meters. And what you can do here, if you have this on your camera lens, if let's say if I have this, my camera lens set at f/16, and the furthest thing I want to focus on is 10 feet away, I can move this 10 so it's across from the hash mark of 16, and then read over here, and it probably tells me that I have about 1.5 feet to 10 feet in focus at f/16. That's a feet and meter scale. But one rule of thumb is, as you're looking at the things that you want in focus from near to far, and it's possible you let some foreground or some background things go out of focus. But if you look at what you want in focus from near to far, and so this is a little drawing I did digitally, I think probably in Photoshop. But anyway, we'll call this a can, and this is a tree in the background. If those are the two things I want in focus, rather than focus on just the front face of the can or the face of the tree, what I want to do is focus 1/3 the distance between the two objects that I want from near to far to retain in focus. I still have to match that with the f-stop, which controls the amount of depth of field. But just as a rule of thumb, is you focus a little behind the foreground object and a little in front of the background object that you want to retain in focus. And here's an example of selective focus. This is a William Klein photograph, and you can see the kids hopefully are playing with a toy gun, jamming it towards the photographer's face. You can see this sort of horrible expression on the kid's face. Well, Klein just let the foreground go out of focus. So what it does is it pushes us past that. We're kind of trained to look at what's in focus as important. It pushes us past the gun and to the expression on the face, which is probably the most important part of the photograph. We can still read the gun and we still understand that. There's enough detail there that we still pick up what's going on. But the use of selected focus here allows the photographer that creative control to move our focus away from one thing and onto another.